everyone, it's Miss Julianne from the Wakanda Area Library, and I am here with January's STEM lesson. So we are learning about the science of sledding, and luckily for you, right now we have snow outside. So you can totally apply this to yourself when you actually go sledding, or you can apply it to the little snow person I made for you and the inclined plane you can create with the papers that I have for you. So, the science of sledding. So we're going to talk about Isaac Newton's laws of motion. Who's Isaac Newton? Well, besides being a really old dude that sadly has already passed because he lived a long time ago, he was this awesome scientist who discovered a lot of stuff about physics. In fact, he learned a lot about how we move and how objects move. And he created a lot of laws in the field of physics, not actual like state laws like wear a seatbelt. And these are called the laws of motion. So in order to explain the science of sledding, we're going to talk about the first two laws of motion. So the first law of motion that Isaac Newton talked about is talking about how we move, right? So we're going to pretend that you and your sled are well, we're not pretending, they're real, but we're going to consider you objects, right? You cannot move unless another force acts upon you. So you need to push yourself off the hill, right, if you're sledding, or maybe you have a grown-up or a friend push you, but an object at rest will stay at rest unless acted upon. So you need to think about that. The next part of that first law is it goes the other way around too. Once you are in motion, you need to have an act of force that is either equal to or greater than you to stop you from moving. So to start moving, you need a force to act upon you, and to stop moving, you need a force to act upon you. Now, while you're doing this, it's called inertia is the push to get you moving. And once you're moving, gravity is the force that is pulling you down, right? Because you're going down a slope or a hill, and that's gravity pulling you down. So there's a couple different ways that there might be a force that acts upon you to stop you. Sometimes you put your arms out, right? Sometimes you put your feet out. Sometimes you might have a friend or a grown-up stop you. Sometimes you might even naturally stop. When you naturally stop, that is the friction between the sled and the snow. So what we consider friction is when it is not, so like you might even hear frictionless plane. So that kind of more or less means smooth. So think about a ball. A ball rolls best when there's not a lot of friction, so on a smooth surface. It's not going to roll as good on a carpet as it would maybe on tile. So think about that as snow. Fresh snow might have a sled move less than packed down smooth snow. So gravity is what pulls you down and has you moving, right? That turns your inertia into movement. And then the force that stops you is usually yourself, a friend, hopefully not a tree, and friction between the sled and the snow. So if that's the first law of motion, what's the second law of motion? Well, the second law of motion is kind of involves weight or force of strength, right? What it means is it's going to be harder to get your sled moving if you have more people on your sled. So if it's you and your friend, you might need to push a little bit harder because you're going to need a greater force. But it also means that with a greater force, you're going to move faster. You're going to have more inertia, and gravity is going to be a force that pulls you down faster. So the more push you have and the more weight you have in your sled, the faster you will go. So think about that. Have you ever gone faster with a sibling or a friend in the sled with you? What about if you have a grown-up with you? Do you need a grown-up to push you? And then who stops you? How do you stop? Does a grown-up stop you? These are things to think about while you're sledding or while you are trying to create a slope for your snowman or snow person to slide down. So think about this when you're doing your experiment. What kind of condition do you think your snow person needs to have in order to be able to slide down their hill that you're going to make? How do you make a hill that works for that? Or when you're sledding, what happens if you add more people to your sled? Or how do you push yourself? Or how do you stop yourself? And how fast do you go? Wouldn't it be really cool if a grown-up or a friend could time you while you go sledding? That would be a lot of fun. I think you should think about that. And that is the science of sledding. And now I'm going to show you how we do the experiment. Okay, so you can see that the first ramp I'm gonna try is my blue paper. Now you might notice that the paper I gave you is like cardstock, it's stiffer. You'll need a paper that gives you some more support, so a plain paper isn't gonna work. So I would suggest trying my paper first. Now I'm not gonna use a book or anything to help make it taller, but you can definitely do that. And then you'll notice that I also have tape to try to help mark where mine is going so I can compare. So I'm going to try this one first. And I'm just going to go. Okay, so I think right there. So I'm going to mark it. Now, how do you think I might be able to change this? And when I mark it, I'm going to put the color. So I'm going to say blue number 1. So this was my first trial. How might I try to make it better? Do you think I could make it taller or longer? Now you'll notice I waited till I had access to a table because I think it's flatter and gives me less friction than a carpet. But you might want to try a carpet. I don't know. So let's see, I made this a little flatter. What happens? Oh, well, that made it even shorter. Okay, so I don't think flatter works. Let's try the longer paper, see what happens there. And you notice I still have to push it off, right? Because we need a force to act on it. That's Newton's first law. So let's try something a little taller. And again, what would happen if you may be able to make it a little steeper, like you had books? There's only one way to find out. Okay. So then we're gonna go, oh, well, that's not good. Another reason why you might want books. Okay, let's go. Okay, that didn't go too much farther. Okay, I brought in some books to make it a little taller and maybe give it some stability, and let's see what happens there. Oh, that didn't work out that great. Let's try one more time. Yeah, that didn't seem to make a difference for mine. So now what I'm gonna do is I'm gonna measure. So it looks like my furthest one was the first try with my white one. So I'll start with that. And I have a yardstick, which is 3 feet, but you might just have a ruler or measuring tape. And I'm gonna go on my inches, and it looks to be, to me, about 23 inches. So the length was 23 inches, and the height of my inclined plane, now this was without books, so it was this. I'm gonna measure, and it was about 6.5. 6.5. Okay. Now my second longest was my blue, so I'm gonna measure the height of my blue. And that was when I did it halfway. So I'll cover it half again. And I'm just gonna stick this up here. And that looks to be 5 inches. So 5 inches. And I had it right here. And that distance is about 19. And then let's see, the next one was blue. So I hadn't altered it yet, so it was still 5 inches. And that one was over here, right? Blue number 2. This is why I numbered them. And that was about 7 inches. So there was a bit of a decrease. So looking at my numbers and writing them down on my sheet, I can see that there does seem to be some correlation between maybe the height of my inclined plane or my slope and my distance. I want to know what you guys find out, especially if you use carpet, which has more friction, or maybe even tile, which would have even less friction than this table. Let me know your results, and I hope you have lots of fun. Thank you for joining us for our STEM lesson today. I hope to see you in the library soon. Bye!